Okay, so here are the C-8 notes. So the power rule for derivatives, this is what we used last time. If you have something of the form y equals ax to the n, then its derivative, which is called y prime, sometimes that's one notation for the derivative, then y prime is a times n x to the n minus 1. Now, we already saw earlier how to take the derivative of a constant function using the power rule. And instead of using, okay, so basically we did this last time. So if y equals c, where c is some constant, it could be 5, it could be pi, it could be e to the 7th, just some constant c, then you could write y equals c times x to the 0, because x to the 0 is just 1. And then using the power rule, you get this, but that just ends up being 0 in the end. Now, another perspective on a constant function is this. If y equals c, which is some constant, like 5, then its graph is just a horizontal line that hits the y-axis at whatever that constant value is. And guys, the slope of a horizontal line is 0. Remember, a derivative is just its slope. It's the instantaneous rate of change. It's the slope of the tangent line. But if the graph itself is just a horizontal line, then any tangent line would just, you can't really like hit, I don't know. It would just fall like right on top of the graph anyway. So yeah, basically if you've got a linear function, then there's no sense in talking about a tangent line because the slope is going to be the same at any point anyway. But anyway, the derivative of a horizontal line is 0, so y prime equals 0. So guys, when you see a constant function or a constant term, instead of going through this whole process, just know that the derivative of a constant is 0. All right? And, all right, so for example number 1, we're going to evaluate f prime of 0. So you need to take the derivative. And all right, so let me start asking this question because so basically we're going to learn how to do 3 things in this course and then use these 3 things to solve problems. We're going to find limits, derivatives, and then eventually antiderivatives, which would be going backwards from a derivative. So since all we know are limits and derivatives right now, you have to ask yourself, am I taking a limit or a derivative? So if they're asking you to evaluate f prime of 0, is that a limit or a derivative? It's a derivative. So you need to take the derivative of this first. So we go f prime of x equals. Now, guys, this has how many terms? 1, 2, 3, 4 terms. And the thing about derivatives is that taking the derivative of a whole big function is the same as taking the derivative of its terms separately. So what I'm going to do is this. All right, so I'm going to put the terms separately inside of brackets, and then I'm going to put a prime on the outside. That is, what this prime means is to take the derivative of what's inside. Plus 7/5 x to the 3rd. All right, so the prime, and then there's a minus. The prime means that I'm taking the derivative of what's inside. Okay. Now I can bring down f prime of x. And to take these, all of these guys are of the form ax to the n. This last one is a constant, so we could use that thing. But these are all of the form ax to the n. So this is, I multiply the 3 by the 4, so that's 12x to the 3rd is the derivative of this first term. Plus the derivative of this second term, I got to multiply 7/5 by 3, which is going to be 21/5x to the 2nd. I bring down the minus sign. All right, you could put a 1 here, ax to the n. I multiply the 2 by the 1, which is 2, and then x to the 0. Okay, 1 minus 1 is 0, plus the derivative of 17 is a constant. So you could put an x to the 0 in there and use the power rule, but it's more efficient moving forward to just know this. So that's 0. All right, now let me just write it a little bit more nicely. 12x to the third plus 21 over 5x squared minus x to the 0 is 1, so that's just 2. So that's f prime of x, but that's not what they asked for. They want f prime of 0. So now I go f prime of 0, and I'm just plugging 0. I'm plugging 0 in for the x's. So these two terms are going to become 0, and that's just -2. Okay. So the slope of the tangent line at 0 is -2. Alrighty, now this next one. So first, all right, so I look at this. I want to find dy dx. And guys, dy dx is the same as y prime. I'm going to use prime notation. This is Leibniz notation. This is prime notation. They mean the same thing. They mean, all right, so if you're finding dy dx or y prime, what are you doing? You're taking the derivative. So, yeah, so I'm going to take the derivative of every single term here. And I look and I see 1, 2, 3, 4 terms. The last term is a constant term. So I know when I take the derivative of that last term, it's going to be 0. But these other 3 terms, in order to use power rule, I need them to be able to form ax to the n. So the very first step is not taking the derivative. Okay, I'm not going to go to this. I'm not going to do this first. I'm first going to convert. Okay, I need to convert first before taking the derivative. Need to convert to terms of the form ax to the n. That's what I've got to do first. So this is still y. This is not y prime. I'm not taking the derivative yet. I'm just converting. So y equals, this is 2x to the 3/7 minus 4x to the -5 plus 3/10 x to the -1/2 minus 4. Okay, and now I'm going to put the primes in. So y prime equals, all right, I'm going to have to take the derivative of this minus, I'm going to have to take the derivative of that plus, I'll have to take the derivative of that, prime. Okay, now, guys, I'm going to write here, this is an optional step. We eventually want to skip this step where you separate the terms in the brackets and put the primes outside. You eventually want to skip that step and go right to this next step. So y prime, I multiply the coefficient by the exponent, 6/7 x. 3/7 minus 7/7 is -4/7 minus, and then that's going to be -20 x to the -6 plus -3 over 20 x to the -3/2 minus 0. Okay, now I want to make it look nicer. So y prime equals 6/7 x to the -4/7 plus 20x minus over 20. All right, guys, I am good with this. But if you're doing delta math practice, they're going to want no negative exponents and radical form. So let me just do that for, I'll say note for delta math, this y prime. And I'm just going to do it fast, guys. And if it doesn't make sense to you, you should just, just figure out how I got this. You know how to do this. You might just be a little rusty. So 6 over 7, and then that's the 7th root, plus 20 over x to the 6th, minus 20 over 20. Okay, for delta math, they would probably want something like that. But I'm pretty sure the delta math problems I assigned you, when I think you just would want to plug a number in here anyway. Yeah. Okay. Guys, that's all that I have to say. And yeah, the practice is on delta math. All right, I'll talk to you later.